Okay. Bismillah ar-Rahman ar-Rahim. Now we'll go to section 9.2 where we're talking about series and convergence. Okay. What we have for the series, first we need to distinguish between an infinite series and a sequence. What's the difference between them? A sequence is an ordered collection of numbers. These are numbers, A1, A2, A3, as collection of numbers, ordered. Whereas a series is an infinite sum of terms from a sequence. So it will be A1 plus A2 plus A3 plus AN plus. That will be the series. Okay. Now, for the infinite series, we call it usually infinite series or series, okay? For the infinite series, we need to discuss the convergence, we need what's called nth partial sum. Nth partial sum. What's the nth partial sum? It's like this. S1 will be A1. S2, it's A1 plus A2. S3, it's A1 plus A2 plus A3. And so on until I get Sn. So I have sequence of partial sum, which is all of this Sn. So this sequence will be what? S1, S2, Sn. That will be the sequence of partial sum. And so on. Yeah. I have a sequence of partial sum. Now I check this sequence. If this sequence converges to a value S, then we say the series, look, sequence of partial sum. I collect the sequence of partial sum. If the sequence converges to S, then we say the series, which is the sum of these n terms, converges. Not only that, and the sum or the limit S, which is the sum of these series, will be S. So S is the sum of these, the sum of this series. If that sequence of partial sum diverges, then we say the series diverges. So the sum of a series is the limit of the sequence of partial sum. I'll find first the sequence of partial sum. Then I'll find, S1, S2, S3, then I'll find Sn. Sequence of the nth partial sum, they call it. I have that, so I have the collection of these numbers, sequence, S1, S2 until Sn, and I care about Sn. So since I need to check the convergence of this sequence, so actually I need the limit of Sn. I need the limit of Sn as n goes to infinity. If that is equal to a value S, then that will be the sum of the series. Will be equal to S. And we say the series converges. If this limit diverges, then we say the series diverges. Okay. Usually we have two examples, two main examples where we can find the sum of the series. We have the telescoping series and the geometric series. What is this? The telescoping series? If a series going like this, I have this is A1, this is A2, this is A3, this is A4, and so on. So my Sn in this case of telescopic will be A1 plus A2 plus A3 plus AN. And what will happen? I can rewrite A1 in this way. B1 minus B2. And I can write A2 as B2 minus B3. I write A3, B3 minus B4 plus until I reach, I can write Bn minus 1. This is An. So and the n minus 1 will be Bn minus 1 minus Bn. And then the last one, Bn minus Bn plus 1. Notice, I can cancel this. Also, this one will be cancelled something here. And this one cancelled by something here. This one also cancels. So I have Sn is B1 minus Bn plus 1. So what will be my S? Will be the limit of this as n goes to infinity of B1 minus Bn plus 1. So what I need to check now, I need to check this limit as n goes to infinity, because this is a number. I don't care about it. So I need to check this limit. If this limit exists, then we say the series converge. And that will be B1 minus this limit. And that will be the sum of the series. The sum of the series. If this limit exists, then we say the series converge. And that will give me the sum of the series. So if this is a number, if this is a number, and that is the formula. We'll do examples that will explain it in more details. Now we have the geometric series, which is in this way. AR to the power n minus 1, which is A plus AR plus AR square. I need to check R. If absolute value of R less than 1, then the series converge. Not only that, its sum is what? A over 1 minus R. What is A? Is the first term. What is R? Is the common ratio. Like in this one, if I check AR over A, it will be R. This is the ratio here. The ratio between this and this, AR square over AR, that's still R, and so on. Now, if R is absolute value of R greater than or equal to 1, then the geometric series diverge. The geometric series diverge. So usually you have these two main cases where we can find the sum. Through scoping and geometric. Or if I can know, if I know the partial sum, the nth partial sum, if I know Sn in general. Okay. Notice the Sn, the nth partial sum for this geometric series is this one. A times 1 minus Rn over 1 minus R, which is very clear. If this goes to 0, then I have A over 1 minus R. If this goes to infinity, then I have the divergence. Okay. Because you know Rn, yeah, if Rn in general, if absolute value of R less than 1, then this goes to 0. Otherwise, it will go either to plus or minus infinity. It depends on the negative, positive. Okay, or does not exist in general. Okay. So also we have what's called Nth-term. Nth-term test for divergence. For what? For divergence. This will not work for convergence. Just will tell you about the divergence. What's the idea? We can prove, and if the series is convergent, then the limit is 0. Be careful. This is only one way theorem. Does not mean if the limit is equal to 0, we can conclude something. No, we cannot conclude something. No conclusion. If the limit of the N-term is 0, then we have no conclusion. However, if the limit does not exist, or the limit does not equal to 0, yes, we can conclude the series is divergent. The series is divergent. We can conclude this. Okay. Now we have some properties for the infinite series about the sum and the constant multiple. Yeah, if you have two series and they are convergent, both of them convergent, and the sum of the first is A and the second is B, then what will happen to a constant times the series? I can take the constant out, then it will be the constant times the sum of that series, which is A. The sum of these in two terms, that will be the sum of A and plus B, and the difference is the same. Okay, every non-zero constant multiple, also the divergent. If A is convergent, then it will be CA. If I have summation CAN, where AN divergent. then this one will diverge. And this one will diverges. I know the sum of two convergence series will be convergent. Also, if I have the first one converge and the second one diverge, then the sum diverge. And the difference also diverge. So if one converge, the other one diverge, then for sure their sum or their difference will diverge. Okay, what about if one diverge and the second one diverge? What will happen? No conclusion. We cannot conclude. All possibilities are there. So if two series converge, their sum converge, and just you add the sum of these two series. If one of them converge, the other one diverge, then their sum or their difference diverge. If both diverge, no conclusion. Okay. Now let us go to the example. Let us go to the examples. Okay. First one. This one is what? Summation n equal 1 to infinity, 1 over 2 to the power n. Okay. I want to write it in the same format. Look at the format. Summation n equal 1 to infinity, a r to the power n minus 1. Let me put the format here. N equal 1 to infinity, a r to the power n minus 1. That is a over 1 minus r. F absolute value of r less than 1. That's what we have here. Okay, that's what we have here. Okay. Now let me try to write it in this way. So that will be summation n equal 1 to infinity, half to the power n. Is it in this format? No. I need r to the power n minus 1. My r should be half. Yeah. But I want to write it in this way. So it will be summation n equal 1 to infinity, half to the power n minus 1. So I need to multiply by what? By half. Yeah. So now what I have, this will be a, and that will be r. Very clear. So the sum s will be a over. So first, before I go to the sum, I say absolute value of r, absolute value of half. I have a equal half and r equal half, which is less than 1. So the series converges. The series converges. Not only that, and the sum of the series and the sum is S, which is A over 1 minus R. What is A? A is half, 1 minus half, which is equal to 1. Okay, this is one way to do it. And I try to do in this format, and then I find A and R. Another way, look at this. A is the first term, R is the common ratio. Let us apply it in this example. What is my first term? Half. This is A. The ratio, look at this. R 1 over 4 over half. This over this, which is half. R this over this. 1 over 8 over 1. It should be the same. Half. And so on. So for sure, R is what? Half. So I know A equal half, the first term, and R equal half. Then I apply the same thing, which is clear. This is for the geometric series. Now this is for telescoping series. Okay, we agreed Sn is A1 plus A2 plus A3 plus An minus 1 plus An. Okay, so this is my An. What will be A1? Let me do it in steps. A1 will be what? Yeah. A1 will be 1 over 1, which is 1 minus half. I'm doing it in details. A2 will be what? 1 over 2 minus 1 over 3. A3, 1 over 3 minus 1 over 4, blah, blah, blah. An minus 1, it will be 1 over n minus 1 minus 1 over n. An 1 over n minus 1 over n plus 1. That's the first example, so I'm doing it in details. So what will be Sn? Sn will be A1 plus A2 plus A3 plus An minus 1 plus An. Let us see what will happen. A1, 1 minus half. A2, half minus 1 over 3. A3, 1 over 3 minus 1 over 4 plus An minus 1, 1 over n minus 1 minus 1 over n. 1 over n minus 1 over n plus 1. Okay, now we should notice cancellation. This cancelled with this. This cancelled with this. This will cancel with someone here. This will cancel with someone here. This cancelled. So what I have, Sn will be 1 minus 1 over n plus 1. Okay. So what will be my S? S will be the limit as n goes to infinity of Sn. Yeah, the general one. Yeah. I know S, we said that the limit of Sn, this is will be S. And that is equal to what? Limit n goes to infinity. 1 minus 1 over n plus 1. And that is what? 1. What is the limit of this? 0. That will be 1. So the series converges and its limit, but its sum, not limit, its sum is S, which is 1. That will be the conclusion. Yeah. By the way, I forget one thing here about the geometric series. Yeah. This is the R, huh? Yeah. The N-term, the Sn, the n to partial sum, you can prove in Sn in this case, Sn in this case, this is the sequence of partial sum, will be that. And that controlled, so Sn, yeah, I'm concerned, these are numbers, A1, 1 minus R, so I'm concerned only about Rn. So I notice f, absolute value of R less than 1, then what will happen to Rn? Rn goes to 0 as n goes to infinity. I mean, because I need to find S is the limit as n goes to infinity of Sn. So if absolute value of R less than 1, then Rn goes to 0. So all of this goes to 0. So you have A over 1 over R. However, if absolute value of R, greater than or equal to 1, then what will happen to Rn? It will go to either infinity or minus infinity. It will not converge. Then S, then this sequence, then the limit as Sn as n goes to infinity. Yeah. It depends if it is negative or positive. Yeah. So it will be does not exist or go to plus or minus infinity. Yeah. So we say it will. So we say this sequence diverge. So the sequence diverge does not exist. Let me say. So the sequence diverge goes to infinity. Okay. Yeah. Now we look at this series sequence. The N-term is what here? The N-term is 1. This is the N-term. This is An. Yeah, you notice what is the limit of An as n goes to infinity? Since it's a constant, that will be 1, not equal to 0. Right away, I'll look at this one. If the limit is not equal to 0 or does not exist, then we say the series is what? Divergence. So right away, I write the series diverges.